Hey everyone, wanted to get in here and do a video to give you a quick demonstration on how the CoreiENC works with this CoreiRST product. Now, the CoreiENC is a DB2 encryption at rest product that utilizes field procedures and it'll implement transparent encryption on your DB2 data. What that means is that your application layer, for the most part, remains completely unaffected. You don't have to go in and make changes to accommodate for the encryption that you set on your data. Um, so there are a couple of small cases where it does produce side effects into your application layer, but we're not going to get into that in this video. We're just going to do a demonstration to see the data encrypted, and then you go over to the CoreiRST product, which is the web services and REST, and we're going to generate a request off platform to pull that at rest encrypted data and see how it remains masked all the way from being invoked and pulled from the DB2 database all the way up through the HTTP pipe and to the client side. All right, let's go through here and it'll make more sense as I walk through it. So first thing what we got to do over here in CoreiENC is we've got a file set up and we want to go in and do some encryption on it. This is a reminder that you've got to have exclusive allocation to the file field that you intend to encrypt, decrypt. Nobody can be in it. Nobody is. So what we have here is we've got our library. It's our CoreiRST library, and we're using this file. It's a test file that ships with the product, and we've got an account number field in there. It's a 10-digit long account number, just like a bank account number. And let's take a look at the details of this. We've got our key information set up. This is our local key store information. And of course, again, the data we're encrypting and where this field procedure is going to be produced and where it's going to live. And ideally, you can specify any library for it to go to, but we're obviously going to want to keep it probably with the file itself for administration type reasons. So it's going to go in the same library. The status is currently decrypted. And you know what? Let's just do a quick let's do a quick query just to take a look at it. Actually, yeah, let's go over to the REST product. We're going to go in, we're going to invoke one of the services that are on top of it, and that's on that file, and that would be the customer bank account information. So if we can run this request locally, so it doesn't even use the HTTP, it's running locally here on the system. Take a quick look at it with a 7, and we will get our response. Here's the customer data. First of all, let me show you what we're requesting. We're going to be asking for 2 customer numbers, customer number 1, customer number 2. And so in our response, we will be seeing both of those come back with the requested payloads for them. And so there's customer number 1. And down here, it pulls the account number. And it's currently, you see, it's the full clear text account number. It's not encrypted nor masked. So because it's encrypted, it's not going to be masked. So there's that. So let's flip back over to CoreiENC and let's encrypt this guy. Simple option 6, encrypt it. It's going through an encryption process and it's going through all the records, encrypting them. And it was successful. So we now have encrypted data on that particular file for that particular field. And if we go back into the same process we just looked at and run it locally here, we'll get to the postman and running this off platform. But here locally, if we run it again, let's see what we see. We see the masked value now. It's all 9s because the data is encrypted. And then whenever encrypted data is invoked for a particular user profile that has settings for masking, then it's going to do the masking. So if we look at the user profiles that's set up for masking for this guy, we've got, anytime you do encryption, it creates 2 default masking records. One is public for everybody other than everybody out there. All the user profiles are defaulted to all. Everything's going to be masked. So, and then for the user profile that actually set the encryption, which is usually going to be a security administrator, somebody appointed by a security officer to do this type of stuff, it's going to give it no masking. So you can do a quick look. So on CoreiAdmin user profile, if we take a look at it, we won't see any masking. And then of course over here for public, we are using CoreiSec user profile. And so that would fall under public. It's not CoreiAdmin. And it says masking is all. So what we got was every digit was masked for this particular case. So let's go over here and let's just take a look at the data with CoreiAdmin, which is star none. Well, we should see the clear text value of it still. We'll just go into SQL and request it here. And there you have it. The account number is clear text value and no masking on it. The data is encrypted, and every time that field proc fires, it's going to go through a masking routine, and based on user profile, it's going to switch it to what's desired. So let's continue, and let's go back in there, and let's change something. Let's just simply, there's the encrypted record or file and rows. Let's go and change the masking from star all for public and change it over to first six. So just the first six digits are going to be masked. Now with field procs, what happens is for every sign-on session, even if you change the masking for somebody who's signed on, it's not going to automatically take effect. They will need to sign off and back on to pick up the new field procedure masking option. So if we run this again over here, we're going to see the same all digits are going to be masked. And there they are, masked. So let's sign off and back on. And let's get our library list right. And let's go back in here and look at that and make a request. And we will see that only the first six are now masked. The last four digits are clear. You can see them. So that's just with the option of first six. Again, CoreiAdmin would see the same clear text value if we did a query over there. Okay, well, that's great. It works here good locally on the IBMI. So let's jump out the Postman and make an HTTP request for the same data. Here's our URL. Here's our endpoint. There's what we're going to be calling. Here's the body, which is going to be the same request for customer number 1 and customer number 2. And this sign on, let's see who this is. This is actually, it's the same sign on as these guys over here. It's CoreiSec. So what we should see, let's see what we see. And then we can make some adjustments to make it work right or make it change. Okay, we get the same thing. I didn't know if the server was already up and we already had a sign on for CoreiSec, and it might have been retained in some other, but it must have created a new job under the servers, and we're getting the accurate first six masking right here, as you see. Let's look at JSON. There's your customer information, and then when it goes and gets the account, which is encrypted, it's going to pull it over that way. So you know what? Let's just turn off encryption altogether, which is going to remove the masking, obviously, and see what we get. Don't want to get too long in this demo. So, all right, the data is encrypted. We want to remove encryption, which is obviously going to remove the masking. Option 7. So it's going through it, it's decrypting and taking all the encryption off. So if we look over here locally, now because we didn't change a masking option, we went straight from encrypted data to decrypted data. It removes it all together, so you will pick up the change with the same sign-on. It's only when you change the masking option with data already encrypted. So right here, we should see the clear text value again. And we do. So we run it, and it goes out, and it pulls the data, and we start seeing the clear text again. So that's great. Let's go out to Postman and get an HTTP request off platform to see the same thing. You see our last request ported in as the first six. We're going to just do the same thing, same user. And we'll be getting clear text value this time. And there it is, right there, clear text. That's how easy it is to encrypt, decrypt, turn masking on, change masking options, and even pull that data off the IBMI and have the same effects of the masking work for any of the consumers off platform. It's all user profile based, and in here we can obviously set up as many user profiles for this field procedure as we want to scale the amount of users that we want to have different masking options. By default, when you create the encryption, it creates the two user profile records, the one whoever encrypted it, and then also one for everybody else, which is store public. But then you could also go in here and create more users for this particular masking options if the data is encrypted, and just set it according to user profile. And everything will work how we just saw it with these two user profiles in this example. Hope you liked it. I think it's super cool, and these products work very good together. All right, thank you.